Hello everyone. In this video, I'm going to talk about how to use region of interest tools. Now you can draw a region of interest so that only particles within the region of interest can be masked. And there are two types of region of interest. One type is labeled in yellow here. That's the normal regular region of interest tool. And then you can use that to restrict masking inside specific image features such as the protein on the DNA in order to analyze that features. The other type of region of interest is the inverse region of interest, which is labeled in blue here. And I can use that to restrict masking outside specific image features so that you can avoid set features. And in this case, the inverse region of interest is used to prevent the DNA tracing from passing through the inverse region of interest. Now, to do a region of interest, so once you enable that tool, you simply drag a polygon around the features you want to restrict. So in this case, I draw a region of interest here so that I restrict masking only to the protein on the DNAs. Okay. Now it's a very powerful tool, especially if you want to analyze proteins on the DNA, for example, right? You want to analyze the matrix of the protein, but without masking the whole thing. Now you have to use the region of interest so that it can localize your masking from within your region of interest. So I liken that as a molecular scissor. So like in the image analysis sense, right, you can use this molecular scissor to cut or crop your particle of interest, including the sub features, right, in order to analyze those sub features. So let me show you how to do that. The region of interest tool is available inside region inspector. You can access the region of interest tools from under the Analyze tab. And you see that we have three options: draw region of interest, draw inverse region of interest, and remove region of interests. And I've also added them in my toolbar here beneath. Now you can do that yourself. You simply right-click a tool, and then click Add to Toolbar. You can create a new toolbar as well if you want to do that. Just say Create New Toolbar. So, all right. So we have, like, in this DNA molecule, we have two complexes. So let's try to draw region of interest if you want to analyze them. So let's just crop this protein complex here. Okay. So we can do another one. So here I'm going to show you a bit of a trick that I would sometimes it's good to know. So for example, if I draw the region of interest like this way, I'm not drawing this very precisely. All right. So for you to see the masking better, I can turn off the transparency of the mask. So you see that the mask is restricted within our region of interests. And you see that although the first one is done a good job, right, because I crop these in a more precise manner, but the second one, so you see there's a little bit of shadows, I'll call that. I mean, the mask, it bleeds out beyond the protein complex. You can see that, right? So and then we not want that, right? And let me show you clearly if I turn off the mask. Now the left bit of little exclusion might be real. Maybe just the DNA ends that extends beyond this protein, and that leaves a little bit of a bubble there. But the right edge, this is definitely bleeding, and especially since this is a high trace uh, channel. So the scan direction it scans from left to right. So this is a typical AFM image artifact, right? It bleeds. Uh, so just in the direction of the scan, right? If the scan scans from left to right, usually there's a little bit of bleed on the right edge of the feature that you're seeing now. If you can adjust the integral gain a little bit higher, that can mitigate this issue. But sometimes the integrated gain is too low, and that will make this issue more pronounced. So you have a bit of a blown up version of the protein complex, right, in the direction of the scan. So, and in this case, I would like to get rid of that bleeding, right? So, how to do that? Okay, I can either make a better region of interest. Right? I can redraw that because right now I'm not doing it in a precise manner. I mean, I can do a more precise version of this crop, right? Or, I mean, sometimes we cannot guarantee that we can draw everything correctly in the first go, right? So if you want to remedy that situation, you don't have to redraw that. You simply use the draw inverse region of interest tool. So in this case, you can simply draw the inverse region of interest inside the region of interest. Now that's a cool trick that can be useful in this situation. For example, like this, I can draw an inverse region of interest, just to crop out that unwanted bleed, right? Now it's gone, right? Let's go turn off the transparency. Yes, so that get rid of that little bit of bleed. And you can do the same thing if you, I mean, just note that if you draw the region of interest first, then you can always draw an inverse region of interest to further refine your original region of interest, right? On the other hand, right, if you draw an inverse region of interest first, right, which to basically to exclude some area, then if you want to refine that inverse region of interest, right, maybe you still want something from within that area. Now you can then draw a region of interest inside that inverse region of interest to get that feature back. I'm not going to show you what I meant. That's a mouthful. So for example, if I, let's turn the transparency on. Now if I simply draw a inverse region of interest, for example, this DNA here is connected, right? So we don't want that one. We don't want them to be disconnected. And also this protein, right, it may not pass this protein complex very well because it kind of bleeds on top, right? So let's just make it one example. If I want to say I'm drawing an inverse region of interest, right? I did some accidentally, right? I cut off the DNA, and that's unwanted, right? Now the DNA is disconnected, right? You see? I click the DNA molecule, so it's not passing through this this block that I put here. So if I want to reconnect the DNA, I want to draw the region of interest inside of that inverse region of interest in order to bring that missing DNA back, right? To remask that part. Now it's fine, right? That's exactly what we want. So, and you can also draw yeah, and I already showed you that you can draw multiple region of interest, and the same thing is true for inverse region of interest, right? You can draw inverse region of interest here, right? And you can also draw another inverse region of interest there to make your tracing as good as it can be. So you can combine these region of interest, right, to make your DNA tracing as best as good as possible, right? And I use the region of interest tool to basically analyze the metrics of the protein complex, right? So once you draw that, you can click inside this region of interest and gives you the information of the particle matrix, right? Then we can record that information in our records table. Let me show you that. Let me just make these two complexes first. So I click first complex. Then I can simply say right click and let's say record all parameters. So now you see there's one row here that basically copies the information on the top table to the bottom table. Now I'm going to do the same thing again for the second complex. I can right click this table and click record all parameters. Now we have the second row, which has all the particle parameters for the second complex. So ideally, we would want to combine these recording of the particle matrix with the recording of positions. Now, in that case, you would first record the particle, the DNA positions. To do the position, to do the DNA tracing and the record its position first, right? So in this case, we have two proteins, so that would have two peaks, right, in the trace diagram, right? And then we result into position recordings. Then we can crop the protein complex and then select each row and then copy their metrics and put them down to our records table. So that's our typical workflow. If we also want to include their positional information as well. All right, so that's pretty much for this video on how to use the region of interest tool. I hope you enjoy it. Thanks for watching. I will see you next time.